happening outside. The Eyewall happened and disappears, but eventually they got organized and got surrounded to form the concentric eyewall. But later on, they break down and then it becomes a monopole vortex again. So this data gives us a very good opportunity to analyze what happened. And this has been done by my student Yixuan Huang. She's showing that in the poster outside. And one key feature is that if we stop the assimilation earlier, actually all the ensemble, 28 ensembles, were not very good in capturing the track, and there's huge spread in terms of ensemble members, and also there's no concentric eyewall. But if we have more data assimilated and let it go, and we will see a much better forecast, and with very reduced ensemble uncertainty. And plus, we can also see the concentric eyewall feature. So work has been carried out by Yixuan to try to understand what happened during the process through a number of different experiments. She can explore what lead to, whether it's the dynamics or it's the moisture field that really caused the happening of the secondary eyewall. So that is another study she will be showing outside. So let me finally move on to another interesting case. So after that, the tropical cyclone Sinlaku hit Taiwan. So let me show you a topic that is probably related to today's, the main theme of this workshop on Morakot. Well, this is Sinlaku, but we see that this is the ensemble forecast in the final stage. It looks very good. 72-hour mean ensemble mean forecast is on the order of about 100 kilometers, which is not bad. However, if you look at the overall ensemble distribution, you see that there's a huge spread. And so the track actually is hitting everywhere in the northern, from the central to northern Taiwan or outside of Taiwan. And if you look at its impact to the precipitation in Taiwan, in this particular simulation, with about 3-kilometer resolution, we see that this is observation, and this is some of the ensemble members we try to show. We see that all the models, all the ensemble members would be able to capture the rainfall in the northern part of Taiwan, but they fail in the peak in the central Taiwan. So there are some with higher predictability, some with low predictability. But if you look at this in another diagram, here we show you the rainfall and accumulation probability density function, and the observation from all 400 rain gauges in Taiwan is this curve. And we show that there's high uncertainty from each ensemble members, given the different tracks. What is also of interest is that there's a curve, the yellow one has the best fit to the observation, but it doesn't have the best track. The one with the best track is the blue one, the light blue one, but it's way off. So that means it is possible that, well, there are two things we can learn from this experiment. One is the track really affects the precipitation patterns. The second is, even we got the rainfall right, it could be wrong. It could be right for the wrong reason. As shown here, the track which is not good gives the better fit. But this comes to another issue, is about how you define the metrics to measure the predictability or accuracy of your rainfall forecast. This is just one of the proxy of the metric. But if you look at it in different other ways, maybe you would have different results. But this shows the challenge about the rainfall forecast, and which is probably related to Morakot, which we will study later based on this ensemble technique to assess the impact of the two Morakot, which we'll study by Dr. Yan right now. So let me conclude by saying that, well, I briefly show you today about dot star and P-part and about the idea on targeted observation, but probably not in detail, then about its impact, and then eventually how we do the ENKF data assimilation to understand this process. And in particular, the case of Sinlaku has been highlighted to show the impact of the data. So the future challenge, there are a number of work that can be done and should be done, which we are doing right now, to see how we can further validate these data, including other data, including satellite or radars. And the other thing is about the understanding and interpretation of these impacts. And we are still working on the ENKF data assimilation to do further dynamical analysis. So with all this, we are still in progress on this problem. Finally, I just want to mention that we are also working on the TC Ocean Interaction Project, which EE mentioned yesterday as ITOP, which can be also interpreted as EE is the top, that's ITOP. Yeah. Okay, so we'll work on that this summer, so we welcome your participation of this project. Thank you.
Questions? Very interesting talk, yeah. Questions? No? Okay, then thank you again, Chun-Chieh.